Alright, in the troposphere, as altitude increases, which of these is going to happen? Just in the troposphere.
Oh, yeah.
Temperature decreases. Alright, so this is just in the troposphere. So remember, as we're leaving the Earth, the sun's warming up the Earth. We did an investigation where we saw how water's heated up, how the soil's heated up. And that soil and water are going to give off its heat to the air above it. So the farther away from that heat source where it's heating up the Earth that we move in the troposphere, this is the layer we're in, it's going to get cooler and cooler. Temperature is going to decrease. Alright, Jaquan has moved up in the, in autumn, they're high now. And for this investigation, or for this class, they did a think, ink, pair, share. They used their notebooks to record observations and their reasoning, and of course then to record notes from what we had in our class discussion. You're going to write down some observations. Now, you don't need to be writing while I'm doing it, because if you do, you're probably going to miss something. So I want you to just watch and think about what's going on, and then I'm going to ask you to stop and think about what you saw and to write down your observation, and to also think about why you saw what you saw happen. What do you think is going on? Now, this has to do with what we've been learning about the atmosphere. So, what is our atmosphere made of?
Layers of gas.
Layers of gas, and of course, another definition we might have for atmosphere is what else besides layers of gas? That's around us right now.
Air.
Air, yeah. So the air is made up of all those gases that make up our layers in our atmosphere. So we normally just refer to as air that's all around us. So right now in this room, there's air all around us. Anything that has an empty space, there's going to be air in it. So keep that in mind as I'm doing your demonstration. So I have here, just to write down, there's not anything in the can. It's open on the end. I am turned upside down, nothing's coming out. Okay? I am going to put just a couple of drops of water in it because I want you to see when it's getting hot. Let's see, I believe you can see fine. Maybe about 5 drops of water in there. Okay, I have in this container some ice water. See the ice in it? It's very cold. You don't feel the bottom of it? Does it feel cold? Okay, it's very cold. So keep in mind that that's what is in my container here, because I'm going to use that in a minute. I have my hot plate on, which is getting pretty hot. It's about as close as I can put my hand right now without it being too hot. And the only thing that I'm going to do is to take my can. I'm going to hold it very lightly right here on the bottom so I don't lose it. And right here, this is where the hardest part is, so it's hard to crush there. So I'm not going to press on it, and I want to put it there so I'm not pushing in on it. So I'm not going to be pushing in on it, I'm just going to be holding it. Let's see, maybe a little higher because the heat, I don't want it to melt my thing off there. And I'm going to put this on here. You should be able to see a little bit of steam coming out. And what would be making the steam?
The water.
As the water is heating and evaporation's going on. So you're going to see a little bit of steam come out, and that lets me know that, of course, the water inside of here has been heating up and that it's evaporating, and you'll see the steam coming out the top. Chandler?
I was going to say, I've seen this on a YouTube video.
I'm going to heat this up on here, and then I'm going to turn it over into the cold water. So you need to watch and watch carefully so you can think about what happens, because you'll be writing your observation down. Don't try to write while I'm doing it. And then I'm going to ask you to think about why that happens. All right? So let's give it just a minute. What's inside the can that the can is heating up? Water, because we said, yeah, I see some steam. Do you see it? A little bit coming out now. So it's heating up the water. The can's touching the water, heating up the water. Is it going to be heating up anything else?
The can.
Besides the can.
The water.
Now hopefully they're going to come loose when I let go of it in a second. You see any more steam coming out? No. I'll give it just another second then. Alright, now. This is the first time I've never had it work for me. Tried it in class. Who knows? I don't know what's going on with it. But this is what happened before. Whenever I put it in here, it went and collapsed. And I'll try to get it in the class and see what happens and see what's going on. So just think about that for just a second though. I don't know why it's not working now. Who knows? The only thing I can think that's changed, well, not much has changed. My room feels a little bit warmer in here, but that shouldn't have any effect on it. So if this happened, hey, Autumn?
When heat transfers, it goes from the warmer areas to the colder areas, so the colder area took all the heat from the warmer area.
All right, so the colder area took all the heat from the warmer area. So if I have cold ice water in here, you're saying it took the heat from the can, okay? And when it did that, why did it cause it to crush? Because
it sucked all that hot air out of it.
Suck the hot air out of it?
The can had air. When it took all the air out of it, it just collapsed.
Okay, so you think it took all the air out of it. Okay, does anybody else have any ideas about why it would make it collapse? Chandler?
Because the heat was all clumped up together in one little space like that.
Clumped up together in one little space
In the can.
in the can. And then if I turn it over and it crushes like this, then what would happen?
All the hot air would go down to the cold air.
The hot air would be going down to the cold air? Is that what you're saying? Flowing out?
Yes, ma'am.
Because of, who said heat transfer? Heat transfer from, heat moves from warmer to colder area. Okay? So, alright, so hold on to that idea. And I'll see if hours will work in a minute so you can see for yourselves when we come back. Maybe we just need to leave it alone for a minute. For our lesson that we did with, we were looking at temperature affecting air movement, and we had a demonstration that didn't work very well during that class. For some reason, I haven't quite figured out why yet the can demonstration didn't work for that class. It worked for the other classes. And what we were trying to do was to have children see that as air is heated or cooled, it causes the air to move, the air molecules to move. And so for the first part, I asked them to record their observation for the can demonstration. Then we had some discussion about what happened, and I asked them to share what they thought happened and the reason for it happening. All right, so this is what we're going to do to help us to think about this a little bit more. You're going to do an investigation at the back. On the table, you have a couple of containers. One of them has some ice in it, and so if it doesn't have water in it, you need to put just a little bit of water in it because you're going to sit your container down in it. I'm going to bring some very hot water around, so be very careful with it when I bring it to your group, and I'm going to pour just a little bit of hot water into your container. You have some very simple procedures. You have a balloon that is sealing up the top of your container, your little flask that you have on your table. And so right now, the only thing that's in the flask is what?
Air.
Air. There's not any water. There's not anything else in it. So as you're looking at this, you're going to be placing your container. You're going to be placing the flask with the balloon on. You're not going to take the balloon off. You're going to be placing the flask in the container with it sitting up with the balloon on top of it. You're not going to take the balloon off at any time. So there's not going to be any air getting into it or out of it because it'll be nice and sealed around the top of it. And there are a couple of places on your procedures where it asks you to do observation. You're going to need one person who's going to be your timekeeper because you have to observe for a couple of minutes and then write your observations. And then you have a question that you're going to answer. With your partners, your question that you have at the bottom, and then you're going to be ready to share that when you come back to the front. And we'll try our other investigation again, and then we're going to see what do they have to do with each other. What is the can that I just showed you, and what happened to it? And maybe it'll work then. What does that have to do with what you're seeing at the back of the balloon? How do the two All right, in hot water, what do you see? Anything happening?
It just started to blow up a little bit.
Yeah. What started to blow up? The balloon. All right, so it didn't have this air in it when you started. Okay, how long has it been in there?
Well, 1 minute and 9 seconds now.
When we first put it in the blue bucket, when we first put it in the blue bucket, or bowl, it sucked in all that air because.
Alright, so this is how it looked when you took it out of your ice?
Yes, ma'am.
Alright, so what do you think happened there?
The balloon deflated when we put it in the bowl of cold water. Like all the heat transfer that came from the hot water that was in the glass.
So from here, the heat transferred to the glass and heated this up? Okay, and then?
When we put it in the cold water, the balloon released the heat, like the water vapor, that the evaporation that the heat caused in the balloon.
Okay, so when you had it in here, you had the balloon with air in it. So you told me a while ago that the air came up, and now you're saying that when you put it in here, the heat was transferred back from this air to the beaker to the water. And why would that make this collapse like this and go down into the?
Because all the air is going out of
Into the
water, and that's why
it's going into the water.
I mean, it's going out of the big balloon and then into the beaker.
Into the beaker. Okay, why would it be able to go into the beaker when it's hot water? Why do you think it can do that?
The cold water sucks back the hot air down because the cold water is in here.
Okay, why would the cold water suck the hot air down?
Because hot air goes to cold air.
Hot air goes to cold air. Okay, so you're talking about heat transfer. So we learned that heat is transferred from a higher temperature to a cooler temperature. So that means that you're saying the air that was in here was giving off its heat to
The balloon.
the heat goes into. All right, remember when we learned about heat transfer and we looked at particles, how they move and in fluids. We even did an investigation when we had some blue and red water. Remember that? And we had some hot and some cold, and you saw how they moved and what it looked like.
Yeah, hot
and
water
how.
to the top.
Okay, and you saw how the particles moved and what they looked like with the red and. Think about that as you're answering your last question and what it has to do with this. And then they went to the back and they did an investigation with the balloons, putting a flask covered with a balloon in hot water so they could see that the air as it expands inside, as it's heated up and the molecules move around, that it causes the balloon to get air inside of it as the air is trying to escape from the flask. And they were recording observations for that, and then they put the flask into cold ice water, and they watched as the balloon lost air out of it, and they wrote their observation for that. And then I asked them to discuss with their partners why they thought that the balloon deflated and inflated and what was going on with the air. Please, I'm going to ask some people to share, so if anybody saw something, you need to add when someone shares, and I want you to do that if you saw something else. Let's talk about, first of all, our hot water. When you put your flask with the balloon in the container of hot water, Chandler's group, what did you see happening with the balloon?
The air in the flask.
All right, where did you see steam?
Inside the beaker.
You saw some steam inside of here. And where was it inside of here? Was it on the glass or in the middle, floating around, or where?
Outside.
On the outside here. All right, so you had some steam. Was it just coming up?
Steam against the glass.
Against the glass. So you're saying you saw some little drops of water inside? Okay, so the word for that inside is condensation, yes. So the water, that means that we have some condensation going on. We'll talk a bit more about condensation later because I hear you using some other words for it, but that's what you mean. The water's collecting. Before we were looking at heat transfer with convection, we said these molecules, they start heating up, they move around more, and as they do that, they're going to bump into each other, and they're going to need more space. And as they need more space, where do they go?
Into the balloon.
Into the balloon. If the balloon were not there, where would they have gone?
And air.
Just out into the room. So we wouldn't have known that if we didn't have the balloon there. Okay? So we have some heat transfer going on, but we see that the air is going to be moving away and going faster, and it has to move somewhere. So it went to the balloon. All right, so let's go to the cold part now. So why did this happen? Why did this happen, Peyton? Why do you think it happened? What did you discuss with you? The air molecules are moving farther and farther down and slowing down. So we have some movement going on because of temperature. And then we came back to our seats. We had a class discussion asking them to share their observations and for their reasons why they thought that the air moved. And of course, then I discussed with them what was going on with the air as it was heating up and changing the air pressure and air movement that was taking place. All right, discuss with your partner what you said about how does temperature affect air movement. Share with them what your response is.
I put it was the temperature that
Let's see. Hannah,